Hi guys, myself Kushagra. Today we are going to learn about tree data structure. First we have to understand there are two kinds of data structure, linear and non-linear data structure. Okay, linear examples are linked list, stack, queue, and in non-linear we have tree. First we have linear data structure. Why were we using non-linear data structure? So with linear data structures, they have two drawbacks. If I say, if we have to add, delete or retrieve any data, we have to done in sequential order in linear data structure. First drawback. And in second drawback is that if we want to retrieve any data, as we done in sequential order, if there are n inputs, then it will take big O of n time. Okay, n inputs, it will take n time for that. Okay, we have understand that why we are going to use non-linear data structure over linear data structure. So, what is tree? A tree is a collection of nodes connected by directed edges. Okay, tree is a collection of nodes connected by directed edges. Okay, you can see. So it is a hierarchical data structure. Every node has relation with other node. For example, we can see that 8 is a parent of 3 and 10. 3 is a parent of 1 and 6. Or we can say that 3 is a child of 8. Okay, so there are some terminologies related to tree. We are going to understand it. One node. A tree is a structure consisting one node is called root. 8 is the root of this structure. Nodes with no children are called leaves. 1, 4, 7, 30 are the leaves because they don't have any children. Okay. The depth of node is the number of edges from the root to the node. They are in tree. We have depth and height. So depth is the number of edges from root to node. Root to node means if we want to know what is the depth of 1, then there are from 8 to 3, 3 to 1, there are 2 edges. So the depth of 1 is 2. Height of a node is the number of edges from the node to deepest leaf. Okay, if you want to know what is the height of 3, then we can go like 3 to 6, 3, 6, 4 or 3, 6, 7. Then there are 2 edges in both the case. So the height of 3 is 2. Subtree represent the descendants of a node. So in this we have subtree as 6 as a parent of 4, 7. We can say that this is a subtree. Okay. Level of a node represents the duration of a node. Root node is at 0 level. Sorry, it's O. I've written it's 0. 0 level. 8 is a root. It has 0 level. It is at 0 level. 3 and 10 are at first level. 1, 6, 14 at second level, and 4, 7, 13 at third level. Okay, and one more is that node with same parents are siblings. Okay, 3 and 10 are sibling of, okay, and 1 and 6, 14, sorry, 1 and 6 are sibling. Okay, this I have written the same what I had said right now. You can pause and see what I have written, an example of all this. Okay, we have now study about binary trees. What are binary trees? A tree where each node have no more than two children. Okay, for example, A have B and C. It can't have more than or D as a child of A. Okay, only two children, not more than. There can be one, there can be zero. Okay, one what do you say, a basic rule for binary trees, that left child have value less than root, parent child, and the parent, okay, parent have value less than right child. Okay, means B is less than A and A is less than C. Okay, then types of binary trees. In this I have taken two. One is full binary tree and complete binary tree. A binary tree in which each node has exactly 0 or 2 children is called full binary. For example, in figure A, you can see that there are every node have 2 children or 0 children. Okay. Then a complete binary tree is a tree which is completely filled, with the possible exception of the bottom layer, which is filled from left to right. Okay. In a complete binary tree, every node have 2 children, and it is completed as first we have fill left children, then right, then left, then right, then left, then right. Okay, because B represents complete binary tree. Okay, at last I have taken an example how we in programming construct a tree node. For this I have using structure, and structure struct node, in which we have three types into data. Struct node, a pointer left child, made up pointer left child, and struct node pointer right. Two pointers and one int have declared in this node. Okay. Thank you. Thank you everyone. If you like this video, then hit a like and subscribe to my channel.